Welcome to iLecture Online, and today we're going to talk a little bit more about physics, and in particular physics on momentum and impulse. They're very much related, those two topics, and to give you a good example, here we go. It says here that we have a 1,000-kilogram car moving east at 30 meters per second, and it collides with a 50,000-kilogram truck moving west at 20 meters per second. Assuming that the car becomes stuck on the front of the truck, what will be the final speed and direction of the truck? So this particular problem, there's a collision, and there's two types of collision in physics. We can either have what we call a elastic collision or an inelastic collision. An elastic collision is a collision where the two things hit and then they stick together, so energy is lost. The other type of collision is when it's inelastic, so the two things collide, they bounce back, they both move in an independent way after the collision, and no energy is lost. Now, of course, in the real world, there are not a lot of examples where no energy is lost. So an elastic collision is kind of an approximation of the real world, but to make it easier to work with it, we're going to use these two types of collisions. So in this case, since the car gets stuck on the front of the truck after they collide, lots of energy is lost, and so we call this an inelastic collision. That means that after the collision, they both will move in the same direction at the same speed, which makes the problems a little bit easier. So this is one of those problems that's a little easier to work out when we're dealing with momentum. So if we use the letter P to indicate momentum, we can say that the initial momentum equals the final momentum after the collision. So whatever the momentum is of both the car and the truck before the collision should equal the momentum of the car and the truck together after the collision. And of course, the definition of momentum is mass times velocity. So we can say that mass of the car times the velocity of the car, and I'm going to use small m, small v to indicate the mass and velocity of the car. That's initial, plus the mass times the velocity of the truck initial. So I use big M, big V to indicate that that's the mass and velocity of the big truck. And that should then equal the mass of the car plus the mass of the truck together, because now they're stuck together, times the velocity final of the two put together. All right, now since momentum is a vector quantity, direction is important. So if the car is moving east, let's say that's to the right, and the truck is moving to the west, let's say that's to the left. So east to the right, west to the left. So we do indicate direction. And let's make a little drawing to kind of get a feel of what happens before and after the collision. So we have a car. That's my beautiful car moving to the right. This has mass m with velocity equal to, since it's to the right, a positive 30 meters per second. And then we have the big truck. There we go. There's our big truck. And it's moving to the left at 20 meters per second, so that would be a minus 20 meters per second. And the mass of the truck, big M, is equal to, let's see, 50,000 kilograms. And the mass of the car, let's put it out here, the mass of the car is equal to 1,000 kilograms. I guess it doesn't take a lot of thinking to assume that after the collision, both will be moving to the left. The truck is, of course, much bigger than the car. So after the collision, you can then assume that the truck will still be moving to the left, although probably slower than before. And so then the car would be stuck on the hood of the truck, and then they both will be moving to the left, presumably with some final velocity. And of course, it will be the sum of the two masses put together. So this is the before picture, and that's the after picture. All right, so momentum of both vehicles before the collision, the momentum of both vehicles stuck together after the collision. Now, since we're looking for the final velocity, right, that's what we want to know. Let's solve the equation final velocity. We'll rearrange the equation. We'll move this to the left, we'll move it to the right. So we have m plus big M times v final equals mv initial plus big M, big V initial. And then we divide both sides by the m plus m. We move that over here. So we have m plus big M, like so. And now we have an equation for the final velocity of the truck and the car together. Now let's plug in the values. So we have 1,000 kilograms times the initial velocity, which is 30 meters per second, a positive 30 meters per second, plus the mass of the truck, which is 50,000 kilograms, times the velocity of the truck. Now that's negative 20 meters per second because the truck is moving to the left. And take the whole thing divided by the sum of the two masses, which is 1,000 kilograms plus 50,000 kilograms. All right. At this point, we'll grab our calculator and see what we get. So we get 1,000 times 30, that's 30,000, minus, that's 50,000 times 20. Okay, and then we divide the whole thing by 51,000. And what do we get? The new velocity, V final, is equal to minus 19 meters per second. All right, so that's kind of expected. So the truck starts out moving at 20 meters per second to the left. The car's moving at 30 meters per second. Right after collision, the truck and the car together move to the left at 19 meters per second. Didn't slow the truck down a lot, did it? Not a good idea to hit a big truck with your car. So again, in conclusion, if you're going to figure out how much velocity something has after collision, you know that in any collision, momentum is always conserved, so the initial momentum should always equal the final momentum. You add the two momentums together of the two vehicles before the collision. Remember that since the truck is moving to the left, it's the negative velocity, the car's moved to the right, that's a positive velocity, and then when they stick together, they both have the same final velocity, which makes this type of problem a little bit easier to figure out. And then you solve for V final, and you plug in your numbers, and there you go. And that's how you deal with a simple example of how you calculate the velocity, final velocity after a collision. Okay, our next example, we're going to do one where there is not an inelastic collision. There's actually an elastic collision, which means momentum is conserved as well as energy is conserved, and those are a little bit more difficult. So let me do an example of that.